As the end of the design process approached, Reah updated the Vasari model for the final time to analyse and evaluate the proposed design. The model was updated to include the abutment openings that allowed the moving river structure to land on either side of the river. The land structures and walkways to the north and south of the site were also included. As the design had now progressed technically, Reah inputted a basic specification into Vasari which included construction, insulation and the building heating information, which allowed Vasari to prepare basic building data, estimate annual building performance and also renewable technology potential. The exposed structure was an important part of the design and had to be detailed in accordance with the concept and research that Reah had undertaken during the design stages. She used the standard structural components in Revit to create a fully detailed model to analyse and prepare drawings. She also used the families component in Revit to create structural connections that were bespoke within the frame. Reah detailed the connections in plan and elevation before exporting the family into the structural model. Following the Revit tutorials regarding the building structure, she identified an opportunity to create a more efficient structural design by reducing truss beam depths where loadings and spans could be reduced. As shown in the example, Reah created a lattice truss family with parametric data so that the dimensions could be changed within the structural model. Reah created a detailed solar shading model from the information and analysis undertaken during the Vasari modelling phase. By creating a detailed nested family incorporating subframe and brise-soleil, Reah could control the vertical rotation of the solar shading from within the model. She then analysed daylighting and solar gain, and from this evaluated how the elevation could adapt to seasonal changes and resulting sun position.
It's quite nice, the idea that they're almost sort of just, embedded sort of into the, basically into the sort of banks of the river, and the time just sort of like washes up against here, and just stains all this sort of.
Yeah, that's zone. I mean, what about windows? I mean, I don't know whether the windows are. I think that perhaps the glazing should be kind of right on the very edge of the concrete.
Well, it's a public building, so it's quite nice that when in here you've got views towards this element, towards the river.
I wonder whether the windows should be on the inside face or the outside face, so you really kind of feel the width of that wall to get these kind of framed views out over the other side, because there's a nice kind of church on the hill over there. That might be quite an interesting kind of framed view, that you get from the building.
It's just sort of nice to feel that they are incredibly solid, and then even when we come to have this element sort of across the river, just having these aspects that are kind of punctured out and sort of roots across to the other side. And
I mean, in a sense, when we're just doing the sketch, what you sort of start to realise is that because you can get high up on the hill on both sides, that's like a fifth elevation.
Yeah, the sort of roof lights down one side where you've sort of got aspects that deal with this country park.
Once Reah completed the structural and fabric elements of the design, she began assembling the final model and creating some of the bespoke elements for the abutments. To create the abutment retaining walls, Reah used the component Model in Place tool, as shown in the example. She used this tool to create a path in plan view, which the bespoke structural element could follow. She researched a suitable river retaining wall and prepared sketch section drawings to ensure the design was correct. This allowed her to accurately draw a section within Revit's elevation view, which followed the previously drawn path to create the building element. During the design process, Reah made the decision to taper the abutment curtain cladding. To build this feature in Revit, she used the In-Place Mass tool, as shown in the example. She then created a mass which was the same dimensions as the main bulk of the abutment. Once the dimensions were correct, she modified the mass so that the elevation tapered inwards as per her design. Reah then used the create curtain system, which she applied to the face of the mass. The curtain cladding was made as a bespoke family to the correct dimensions and applied to the system. The advantage of creating the cladding by attaching it to a mass model is the ability to modify the mass if required, and to simply update it to follow the new form. Once all of the elements were completed, Reah began preparing her 2D and 3D drawings using the Revit model.